Okay, we got to cheat a little bit on example 5. We got to go to the future just for a minute and talk about something. Otherwise, we would have to fill up our whole page with this, and I don't think that's what was intended. I want to kind of try to sketch this graph of h of x. All right, so let me do that as best I can, and then we'll talk about what. Oh golly, we'll need to talk. We'll talk about what needs to happen. For us to find out where this thing is differentiable. Okay, where can we find slope values? Okay, so all right, so let's try that again. All right, way better. All right, cool and cool. Okay, now, all right, so coming from the left, before I get to the y-axis, it's this parabola that has been shifted 1 unit to the left. All right, so it does this kind of deal. All right, it's going to hit down here at -1. All right, and then it's a parabola from on this side. Yay. And then I'm going to go right here and stop. And then there's actually a point on that purple because that's equal to. Okay. Now, the next part is the line 2x plus 1. Well, so here's the thing. If this is to be differentiable, then not only do they need to hit each other at the same place, but then the slopes entering this from the left and then entering from the right need to also be the same. So in other words, was this a nice ramp that somebody made? So I had a hill here, and then they made a ramp that's I'm going to put in green. I'm going to go from to 7, and it's going to have an open circle at 7. Let me see if I can get this to look good. All right, so right there is an open circle at 3, 7. And you're like, how'd you know that? Well, I'm going into this one. All right, so if I place 3 right there, though it's less than, that just gives me a boundary. And then if I put a 3 right there, 3 times 2 is 6 plus 1 is 7. All right, so and then right here, I would put an open circle 2, but it just so happens that it hits at 1. When I put 0 in right here, I get 1. So yeah, so I've got continuity here. All right, but the question is, do I have differentiability? Is that slope, the slope of the green is obviously 2. Is the slope of the purple at that moment also 2? That's where we're going to have to cheat a little bit. All right, now over here on this though, we're good because if you put 3 in, 4 minus 3, 4 minus 3 is 1, and 1 squared is 1. So let me change colors for that. Let's go blue. So the blue down here is going to have a closed circle here. All right. And it's going to continue and hit at 4 and be a parabola after that. Something about like that. Okay. So now how did I know that? Well, I substituted 3. 4 minus 3 is 1. 1 squared is 1. And then when I put 4 in, I get 0. And that is going to be the minimum on that because this is a parabola that's completely above or on the x-axis. And then from there, I just continued. All right, so obviously we've got a major issue at 3. Not differentiable there. But the question is, what about right here? Okay, that's what we need to know. Is that a smooth transition? Obviously, it's continuous, but that doesn't imply differentiability. I could have a cusp there that is ever so slight. So in other words, if the purple, the derivative at 0 is not 2, as is the derivative of the green, we've got a little cusp there that we couldn't see. Okay, so I know this slope is 2. The slope of the green is 2. Let's talk about purple. All right, now I'm going to cheat a little bit because x plus 1 squared is the same as x squared plus 2x plus 1. Okay, so this would be h of x until you get to 0. All right, and so then h prime of x until you get to 0. I'm using the power rule. So this is h of x for a little while. All right, for a little while. And then h prime of x in that same location is going to be 2x plus 2. I'm doing the power rule. Yes, we haven't had that formally yet, but otherwise I would have to do a whole lot more work than I'm really willing to do. All right, so here we go then. So the limit, the derivative as you come from the right is 2, and as you come from the left, I can actually substitute in 0 and see what's happening at that moment. All right, so h prime of 0 is going to equal 2 times 0 plus 2, which is also 2. All right, and let me just go ahead and say for the record then And that's equal to the other side, the slope of when the slope was 2x plus 1. So the equals the slope. I don't even know. I don't know. So okay. So really formally, I guess I should say the limit as h approaches 0 from the left of h of sorry, not h. I want to do the alternate form. Let's make that x. Okay, as x approaches 0 from the left of h of x minus h of 0 over x minus 0 is equal to 2. And that's equal to the limit as x approaches 0 from the right, which is the line, the green line, of h of x minus h of 0 over x minus 0. They're both 2. All right, they're both 2. And so therefore, this is also continuous and smooth, also another way of saying continuous and differentiable. So the only place that I have it's not differentiable is going to be at 3. So this function, so I could say h of x is differentiable for all x values except x equals 3. At that point, at x equals 3, the function is not continuous. And that would be good enough because if it's not continuous, it's not differentiable. All right. So I could say therefore not differentiable, but anyone reading that's going to know that you knew it wasn't. It's not differentiable at x equals 3 because it's not continuous. All right. So that works nicely.